Now, here's a bit of a funny situation. I'm going to key in x equals 5 and y equals 5. If I key in x, y, both of them say 5. And now I key in ID of x, comma, an ID of y, and I get the same address. All right, that's fine. Let's now change this to a list. X equals 1, 2, 3. Good. Now I'm going to take x, I'm not going to specify the beginning or the end. That means everything. And I'm going to assign that to y. What do we have now? Well, if I key in x, comma, y, I get 1, 2, 3, 1, 2, 3. But if I key in ID of x, comma, ID of y, we get different locations. Or do we? Are these really different locations? Or is only part of them a different location? Well, what does that mean? Well, to make that clear, let's key in x, comma, y again. X, comma, y again. We have 1, 2, 3, 1, 2, 3. What is the ID of x's 0th character? And what is the ID of y's 0th character? Well, they should be different because the x and y are different, yes? Whoa, surprise is coming. They are the same. Wow. Is that true for every single one of the elements within x and y? Yes, it is. Let's change this 0 to 1 and change this 0 to 1. And the 1th element of both of them, the same address in memory. Well, we have only one more to test out. Let's do that. Change that 1 to a 2. Let's change this 1 to a 2 and see if the 2th element is also pointing to the same area in memory. And it is. So here we have x and y, the two arrays, and placeholder 0, placeholder 1, and placeholder 2 in both of them. And placeholder 0 is pointing to 1, placeholder 1 is pointing to the 2, and placeholder 2, 0, 1, and 2, is pointing to the 3. But that's the same for both of them. They're all the elements within both arrays are pointing to the same data. That's a little bit hard to imagine. Let's draw another picture to make that clearer. So up at the top we have the X array, this area of memory that has placeholders 0, 1, and 2, which is pointing to 1, 2, and 3 in another area of memory. This is over here. This is X's area of memory, which is different from Y's area of memory. But the innards, the constituent elements of each one of these guys, the placeholders of each one of these guys, X and Y, they're all pointing to the same data in a different part of memory, like so. Now if I change this, and I will, if I now say that Y's 0th element should now be equal to, let's say 5, that will take this P sub 0, placeholder 0, and point it to another area of memory where there is a 5, like so. And it will disconnect the P0 placeholder from the previous area, from the previous data, the 1. So after I execute y's 0th element equals 5, the placeholder 0 will be pointing to this 5. X's placeholder 0 will still be pointing to the 1. Let's see how true that is. Remember, x, comma, y, I get 1, 2, 3, 1, 2, 3. And I'm going to say y's 0th element is equal to 5. Now, again, x, y, I would think both of them now would be equal to 5, 2, 3, 5, 2, 3, but they're not. Now, y's element is equal to 5. It's been pointed to a different area in memory, like so. And look, you don't have to worry about it at all. The system is keeping track of everything. But that is what is going on under the hood. This is George Boole. Please share and rate this video, and good luck.